Today we are doing a whiteboard review. We're going to work through some different things. Nothing too crazy, pretty quick, hopefully. We'll see what we can do. Name 5 different techniques we can use to establish identity. So we're just brainstorming here. Talk with your neighbor. What are 5 different things as you look at a problem? Hey, let's try this. If that doesn't work, I try this. Talk with your neighbor. Come up with 5. Go. All right, here we go. Let's name 5 different techniques we can use to establish identities. Joey, what's one? Factoring. Probably, to me, it's kind of the one that I always do last, but factoring could be pretty helpful. If you're stuck somewhere else, you see some squared stuff, always going to factoring is never a bad idea. Other ones here. What you got for us, Megan? Sine and cosine. Rewriting stuff as sine and cosine could help, especially on some easier ones where you're just kind of stuck. If you don't know what else to do, sine and cosine would be pretty helpful. Aaron? Getting common denominators with fractions. If you have 2 things being added or subtracted, 2 fractions, getting common denominators is a key, so we got to make sure we get that correct. Jake?
Conjugates.
Using conjugates. If you see, especially in a denominator, like 1 minus sine theta or 1 plus sine theta, that would be pretty helpful. Okay, rewriting stuff in terms of conjugates. Yeah, and then the last one I would say, substitution. Substituting in something, specifically our Pythagorean identities. Any of our identities would work here, but substituting in something that we know. Sine squared plus cosine squared equals 1, etc. Those would all be helpful. Okay, we're not going to do any establishing identities together today because they could take a lot of time. But those are kind of the steps that we would follow as we look through them. If I put them in order, I would say most important, and then that one, and then that one, and then that one, and then that one, but obviously it just depends on the problem. Okay, now let's actually do some math. Use sum and difference identities to find the exact value. Talk with your neighbor, get an answer, hold it up. Go. It says use sum and difference identities. So obviously we're going to use sum and difference identities. We're doing the exact value, so I need my unit circle. Okay, I look for the pattern. The pattern goes tangent minus tangent. 1 plus tangent over tangent. I look at my identities. That works with tangent of alpha minus beta. My alpha is 100. My beta is 55. So it's tangent of 45. You go on your unit circle. You look at tangent of 45 degrees. Tangent of 45 degrees is 1. Questions on the first one? That's the easy one. Don't miss that one. Next one. I already kind of started the problem for you. You would get this on a problem that's like tangent of negative 15 degrees. You would start off by doing sum and difference identities. You would build that angle by adding or subtracting 2 angles. What angles are you going to avoid if you're doing tangent sum and difference? 30 or 150 or 210 or 330. You'd plug in, you'd simplify, you'd get to this step right here. But you can't leave it that way because you got a radical on bottom. Simplify that the rest of the way so there's no longer a radical on bottom. Go. We're doing well here. Just make sure you can do it correctly. I'm going to go quick because you mostly got it right. You're multiplying by the conjugate, so it's 1 plus radical 3. Whatever's in front of the radical, you change the sign. We multiply the same thing on top and bottom. Then we FOIL. 1 times 1 is 1. 1 times radical 3 is radical 3. Negative radical 3 times 1 is negative radical 3. And negative radical 3 times radical 3 is negative 3. These 2 things cancel. I get negative 2. On top, I get 1 plus radical 3. Plus another radical 3, plus 3. 1 plus 3 gets you 4. Radical 3 plus radical 3 gets you 2 radical 3. Then you simplify. 4 divided by negative 2 is negative 2. Don't forget the negative sign when you simplify. And that divided by negative 2 is going to get me negative radical 3. There's my answer. Yes, ma'am.
I don't know if this matters, but how do you know, earlier when we did the conjugate stuff, we did negative?
Yeah, I'm always going to do, the conjugate is changing the sign of whatever you're trying to get rid of. So since I was trying to get rid of the radical 3, I changed the sign in front of the radical. Okay. The one that was on notes was written funky.
Yeah.
Try the next one here. A little bit longer. Okay, I told you sine of alpha. I'm telling you tangent of beta. Start off by finding alpha and beta using x, y, and r for both of them. Once you have found that, then use it to find sine of alpha plus beta. Talk to your neighbor and go. All right. So we start off by doing alpha and beta. This is sine, so this is y over r. My x is 3. I'm in the first quadrant. It's all positive. Tangent of beta is negative 12 fifths. So this is y over x. So y is 12, x is 5. Pythagorean theorem to find my r, it's 13. Which quadrant am I in if I'm between pi over 2 and pi? The second quadrant, so which thing's going to be negative? X is negative. Once I've done this, then this part's easy. It's sine alpha cosine beta plus cosine alpha sine beta. That's my formula. It's a sum of difference identities. Then we're just plugging in. Sine of alpha is 4/5 y over r. Then it's cosine of beta. Cosine of beta is x over r. So it's negative 5/13. Then it's cosine of alpha. Cosine of alpha, I'm looking here, it's 3/5. And then sine of beta is y over r, it's 12/13. We got common denominators, it's 65 with a negative 20 on top. And then this guy, 3 times 12 is 36 over 65. I get 16 over 65 when I simplify. Make sense of what we did? X, Y, R, plug it in. There's a lot of places you can make a mistake. Just take your time and make sure you don't make a mistake. Next one. Find the exact value of cosine of 112.5 degrees. See what you can do. Cosine of 112.5 degrees. If it's 112.5 degrees, we're finding the exact value, so I'm using my unit circle. What formulas do you think I'm using if I'm doing cosine of 112.5? Half angle identity. So my formula looks like this. It is the square root of 1 plus cosine alpha. So it's cosine of 225 because that's what when I cut in half gets me 112.5 and I'm dividing by 2. It is plus or minus. So then I'm going to do it. Square root of this is 1 plus square root of 225 is actually negative radical 2 all over 2. All over 2. Square rooted. I don't like the 2, so I'm going to multiply everything by 2. So it gets me 2 minus the square root of 2 all over 4, but I'm taking the square root of it. And so now my square root sign doesn't have to be on bottom anymore. But don't forget, it was plus or minus. We need to make that distinction. I'm doing cosine, and it's 112.5. Which quadrant are we looking in if we're looking at 112.5? Second. What is going to be true about cosine if I'm in the second quadrant? It is negative. Questions there? Here we go. Next one. Find the exact value. You've got that and that. You're finding sine of beta divided by 2. Go. A lot of things you could simplify on this one. I think most part we were doing well. You just got to simplify correctly. I started off doing x, y, and r. 12 and 5. One of them's negative. I don't know which one it is. If beta is between 3 pi over 2 and 2 pi, which quadrant am I in? I'm in the fourth quadrant initially. And then, so that means my y is negative. Everybody good there? Let's just deal with the plus or minus at the beginning. I've got sine of beta over 2. And so I'm using this formula. It's the square root of 1 minus cosine alpha divided by 2. It's either plus or minus. Pick your favorite angle in the fourth quadrant, like 300 degrees. If you cut 300 degrees in half, what quadrant am I going to be in? The second quadrant. If I'm in the second quadrant and I'm doing sine, is my answer going to be positive or negative? Positive. I might have given you misinformation as I was checking whiteboards. I think I was checking too quick. It is positive. Everybody kind of see why I'm doing that? Yeah? You seem really excited about it. All right, so it's positive in the end. The square root of 1 minus cosine of alpha, that's going to be minus a negative 12/13 all over 2. I don't like how it's written, so what can I do now? What's up? Oh, I did cosine. I did sine. Blah! 5/13. And it's minus. Lo siento. I was doing sine. Cosine. I don't like this. I want to get rid of the 13, so let's multiply everything by 13. If I do that, I get 13 minus 5 all over 26, and it's square rooted. What's 13 minus 5? 8. It's 8 over 26. Can I reduce 8 over 26? 4 over 13. I'm still square rooted. What's square root of 4? 2. What's square root of 13? Oh no. I've got a square root of 13 on bottom, but that's okay, because all you got to do is then multiply top and bottom by square root of 13. Is that ugly? Absolutely it's ugly, but it's just using... It's fine. That's ugly too. But it's just a matter of using your brain and figuring out the best way to get there. There's other right answers that aren't exactly the same. That's the best simplified answer. Questions?